So today in class, we talked about ionic bonding, and this is Wednesday, the 24th. So the very first thing that we did before we did this sheet, but this is the sheet that you'll need for your practice, is that we did a graphic organizer together in class. And what we talked about, this is on page 54 of your notebook, so let's do that really quickly. Page 54 is where this goes of your notebook. And we talked about the differences in ionic and covalent. So we did a T-chart. And just looking at the basics, because whenever you're naming compounds, the very first question that you're going to ask yourself is, do I have an ionic or do I have a covalent compound? And you have to know the difference in those just by glancing at them. So the very first thing is they're made up of two different things that we've discussed many, many times in class. So the first thing about an ionic one is a metal bonded to a non-metal, where a covalent is two non-metals. So that's the first difference, and you should be able to see that at first glance. If the first element is a metal, then you have an ionic bond. And then we talked about what happens to the electrons in both cases. So over here, the metal is going to be the one that loses an electron or electrons. It could lose more than one. And the non-metal is going to be the one that's going to gain the electrons. Over here, nobody's losing or gaining any electrons. These electrons are being shared. Remember, electrons is my E negative, are shared. So over here, you've got one losing and one gaining, and they're going to become oppositely charged. These guys are just sharing them, and nobody's going to become charged. So let's talk about those charges for just a minute. If my metal loses an electron, it's going to become positive. It's going to have a charge on that metal. It's going to become a positive ion. And the opposite is true over here. If it's gaining an electron, my non-metal is going to become the negative ion. And those two charges are going to attract each other and hold it together, hold the bond together. Over here, these guys are sharing electrons, and there are no charges. Remember, the word ion from the beginning of the year means charged, and that's true for ionic and covalent. Ionics have a charge, covalents do not. So when we're naming these, once you realize this, we learned some prefixes yesterday in class. We learned the prefixes, the Greek prefixes. The mono, the di, tri, so on and so forth, tetra, penta. You've got a list of those if you just flip back in your notebook one page. So those are the prefixes I'm talking about. So to name these, we are going to use Greek prefixes. Yes, yes, yes. Using the Greek prefixes. Over here, write yourself a big note. Do not use prefixes. Do not. Do not. So that's the difference in the two. So then we moved over to here. And again, we've named covalent bonds the day before, and we used our prefixes. Today, it is so easy that you don't even have to use your prefixes at all. So all you do is you follow these steps that are in the word bubbles here. So the first thing is if they give you the formula and you have to give the name of the compound, you name the metal, because the first one's going to be metal, right? Because we're talking about ionic. So calcium is my metal, and then I change the non-metal to IDE. I do not use prefixes. So calcium oxide. Then K stands for potassium, and sulfur, it becomes sulfide. Mg stands for magnesium, and phosphorus is P, so that becomes phosphide. So that's all you have to do there. On this one, if they give you the formula and you have to give the, or they give you the name and you have to give the formula, you're going to get the oxidation number for each element. Remember, the oxidation numbers are on the top of the family. So if I look at my periodic table on page 41 of my notebook, we have our oxidation numbers listed. Okay, so like barium and chlorine, I'm going to use so I've got barium chloride. So barium, I have to go here to my periodic table. I see barium is in family 2, which is going to give me a +2 oxidation number. And then chlorine is over here in family 17, which is a -1 oxidation number. So I found those, and that's how I find those on the periodic table. So barium, we said, was a +2, and chlorine is a -1 charge. So we found the oxidation numbers. Then you're going to crisscross them down to become subscripts. So the 2 goes to be the subscript on chlorine, and the 1 goes to the subscript on barium. So really, I'm saying barium 1 and chlorine 2. Whenever they go down to be subscripts, the charges disappear because you're telling me how many atoms that you have of each one. And remember, this 1 is understood, so you don't have to write it in the final formula. So when you see this, 1 is understood, and you have Cl2. So for number 2, or the second one, calcium fluoride, I get the oxidation number. +2 is calcium. -1 is fluorine. I crisscross those down. The 1 goes to the calcium that I don't have to write, and the fluorine gets 2. Potassium is +1, sulfur is a -2. So I'm going to crisscross those down. So potassium is K, and it gets the 2. It crisscrosses down. Sulfur is S, and it gets the 1, and I don't write the 1. Magnesium is a +2. Phosphorus is a -3. So magnesium is Mg. The 3 comes down to the magnesium. Phosphorus is P, and it gets the 2 crisscrossed from the magnesium there. All right, so rubidium is R. I got to get this, +1, and sulfur is -2. So rubidium is going to get the 2, crisscross down, and selenium is going to get the 1, and so that's that. The last thing you want to do is make sure this ratio is in simplest form. So all of these are in simplest form because a 1-to-2 ratio is simplest form, a 2-to-1, a 3-to-2, a 2-to-2. Let's say, for example, you have something like this. O6, let's say Mg3O6, all right? That is not in simplest form because I can divide both of those by 3, just like a fraction, just like if it were 3/6. If you divide those both by 3, you're going to end up with 1/2. So it's a ratio works exactly the same way. I divide those both by 3, and I get Mg1O2. So I would have a 1-to-2 ratio. So you take that ratio and you reduce it. If I have them the same number, let's say I have Ca2O2. A 2-to-2 ratio can be reduced to a 1-to-1. So I just rewrite it as CaO because I can divide both of those by 2. And that's how you make sure it's in simplest form. So there's practice on the inside. I'm going to post the answers to those on, I'm also going to put them on Remind. So this is the first side. You can just pause, and no, you do not have to have the oxidation numbers up there. I'm only the subscripts. I was just working those out. Then here's the bottom. The other side. Pause and get those. And then the bottom. You can pause and get those. And we're going to have a quiz on the 25th over going 5 each, going forward and going backward. And that's it.